Hello everyone and welcome to your day 2 of higher chemistry. We're learning today about the oxidation of food. You will need to have your notes jotter and some things to write with as we go through today's lesson. The prior learning you should have is being able to identify and name primary, secondary and tertiary alcohols, identify and name carboxylic acids, identify and name aldehydes and ketones, and discuss how oxidizing and reducing agents work. So these are all the things you should be able to do before we start today. If you have any issues with any of them, just pop a wee comment onto Teams and I'll help you with that. Today's new learning, we're going to be working out which molecules can undergo partial oxidation using an oxidizing agent. So that's a new term for us, partial oxidation. I can discuss what happens to the oxygen-hydrogen ratio during oxidation. I can name some oxidizing agents and state relevant color changes. And I can use the terms oxidized and reduced to describe the relationship between organic compounds. So that means we would say, for example, this compound can be reduced to this compound, or this compound can be oxidized to this compound. So talk about chemical processes. And finally, I know how antioxidants work. There's a bit more to antioxidants than what we're going to cover today, but what we will cover today is enough for us to kind of understand the relevance to this subtopic of oxidation of food. So from this point on, pen in your hand, write down notes. Everything that's in the slides should be part of your notes, but you may want to include extra things that I'm explaining if it helps you to understand. Obviously, just pause the video and rewind as you need to. And the slides as a PDF will also be available. So if it's easier for you to print them out and then just highlight them or annotate them like that, that would be absolutely fine too. Okay, so the term oxidation, it should be familiar to us from our work on redox chemistry, both in National 5 and what we've covered in Unit 1 in higher. Redox is a term that applies to reactions where electrons are lost by one species, an atom, ion, or a molecule, and then they're gained by another species, another atom, ion, or molecule. That still applies, but we're going to expand on our definition of oxidation to describe what happens in the simplest forms when we're discussing carbon compounds. So for carbon compounds, oxidation can mean either adding hydrogen, so we literally add in extra oxygen atoms from an oxidizing agent into our carbon molecule, or we remove hydrogen atoms from our carbon compound using an oxidizing agent. So either whether we're adding oxygen or we're removing hydrogen, the key message is that we're increasing the oxygen to hydrogen ratio, or OH ratio. Okay, so we can think about the oxygen as what needs to be shared, and the hydrogen is how many things it needs to be shared amongst. Okay, so the more things we've got to share it amongst, the lower the ratio will be, for example, like 1 to 8 or 1 to 10. But then as we either increase the oxygens or decrease the hydrogens, we might get a ratio like 1 to 4 or 1 to 5 or 1 to 6, and we've increased the oxygen to hydrogen ratio. Okay, so I'll explain a bit more about that as we go on. But the key message here is oxidation can also be used to refer to a change in the oxygen-hydrogen ratio where we're increasing the oxygen or decreasing the hydrogen. Okay, so we can use an oxidizing agent to provide oxygen atoms to a molecule. This is known as partial oxidation. So oxidizing agents are chemicals, which we sometimes call reagents, which will provide oxygen atoms or take away hydrogen atoms to allow that ratio to be increased. This is called partial oxidation because it only changes the bonding in the functional group part of the molecule. It doesn't completely change the bonding. If we were to break all of the bonds in an oxidation reaction, that's called full oxidation, and that would apply, for example, to combustion reactions. So if we think about a combustion reaction, like I've given an example here of the combustion of ethanol, all of the bonds in the ethanol molecule break, and then they all rearrange to form new molecules of carbon dioxide and water when they react with oxygen. Okay, so our understanding of oxidation when it applies to burning is still the same. That is now what we're going to call full oxidation. Okay, so it's still, our understanding of it's still the same, but we can add in what happens, well, if only part of the molecule changes, that's partial oxidation. Okay, that's what we're referring to today. So we can use oxidizing agents to help us distinguish between alcohols. Distinguish just means tell the difference. And remember, we're trying to tell the difference between primary, secondary, and tertiary alcohols. So an alcohol can be partially oxidized if the carbon atom attached to the hydroxyl group has at least one hydrogen atom bonded to it. So I'm going to show you this with a molecule. So here is a molecule of ethanol. Ethanol is an example of a primary alcohol because the hydroxyl group here is attached to a carbon which is attached to one other carbon, okay? And the fact that it's got these two hydrogen atoms here tells us that we can oxidize this, we can react this because we can take away some of these hydrogens, okay? So what happens is we use an oxidizing agent, more on that in a wee second, and we take away this hydrogen atom, and we are also going to take away this hydrogen atom here and reform this as a double bond to oxygen. Okay, so we've changed the bonding just in this part of the molecule. Okay, so now that we've got a carbonyl group. Okay, and this would now be ethanal. Okay, so let's think about that. Let's reverse that. Let's reduce it back. Let's do the opposite. So what we had was the hydroxyl group at the end of the chain. Okay, and then we changed it to be a carbonyl group at the end of the chain. Now, think about this in terms of oxygen to hydrogen ratio. So I've got one oxygen, and I've got 1, 2, 3, 4, 5, 6 hydrogens. So that's a ratio of 1 to 6. One oxygen shared between 6 hydrogens. Okay, so 1 to 6 ratio. When I take away these two hydrogen atoms, can't really show, and I reform this bond here, my new ratio is 1 to 1, 2, 3, 4. So 1 oxygen to 1, 2, 3, 4 hydrogens, 1 to 4. So I've changed from 1 to 6 to 1 to 4. That's an increase in the ratio, because if we think about it, 1 oxygen shared between 6 hydrogens, those hydrogens are getting less than 1 oxygen shared between 4 hydrogens. So each hydrogen is getting a bigger piece of the oxygen, if you like, if we think about it in terms of the ratio. Okay, so that's an oxidation reaction. The ethanol oxidized to ethanal. Okay, I can also do this if I've got a secondary alcohol. So here's an example of propan-2-ol. Okay, so I've got my 1, 2, 3 carbon atoms and then a hydroxyl group on the middle here. So oxygen to hydrogen ratio again, I've got 1 oxygen and I've got 1, 2, 3, 4, 5, 6, 7, 8. So ratio is 1 to 8 for propan-2-ol. I'm going to oxidize this now. So I'm going to take off this hydrogen atom and take off this hydrogen atom. And I'm going to form this as a carbonyl group here. So now this is a ketone. This is propanone now. So I've got 1, 2, 3 carbons, yep, and I've got my ratio, it was 1 to 8, remember, for propan-2-ol, and now it's 1 to 6. Okay, so that's oxidized. Okay, so an alcohol can be partially oxidized if the carbon atom attached to the hydroxyl group has at least 1 hydrogen atom bonded to it. So that's what we just discovered. So the ethanol that was primary, that could be oxidized. And the propan-2-ol that was secondary, that could be oxidized. If I have a tertiary alcohol, so here's a tertiary alcohol, and this is 2-methylpropan-2-ol or methan-propan-2-ol, and this hydroxyl group here, so the hydroxyl group was what was changing in the other examples. I can't change this because there's no hydrogens attached to this carbon atom, okay? It's attached to 3 other carbons. So I can't change this. I can't oxidize this tertiary alcohol, okay? So the key message here is that, the key message here is that primary and secondary alcohols can undergo partial oxidation, but tertiary alcohols cannot. We need to know about the oxidizing agents that can carry this out. So there are 2 main chemicals or reagents we need to know which can oxidize primary and secondary alcohols. The first is acidified potassium dichromate solution. It's not really about the potassium ion, so we could use other dichromate solutions. The key parts are acidified dichromate solution, because the orange dichromate ions are reduced to green chromium ions, chromium 3+. Okay, just a little note here, the SQA still talk about dichromate solution because it's a really obvious color change, but in schools we now don't use dichromate solution because of health and safety issues. We actually use a similar compound called permanganate solution, which has a different color change, but usually this is the main example that's given for oxidizing agent, is the dichromate solution, so it changes from orange to green. We can also oxidize primary and secondary alcohols using hot copper 2 oxide. I think some pupils carried out this experiment before Christmas. So during that reaction, the black copper 2 ions, or the black copper oxide, is reduced to the red copper metal ions. Okay, so we actually see copper forming. Okay, so those are 2 examples of oxidizing agents that oxidize primary and secondary alcohols. They wouldn't work for tertiary alcohols. We need to know the names of those and the relevant color changes. Okay, so we know that primary and secondary alcohols can be oxidized and tertiary alcohols don't. So primary alcohols are oxidized to aldehydes, secondary alcohols are oxidized to ketones. Once we've got our aldehyde and ketone, can we oxidize it any further? Well, the answer is yes. We can look at where the carbonyl group is, and if that carbonyl group is attached to a carbon that still has hydrogens on it, then we can further oxidize it. Aldehydes and ketones with the same number of carbons are isomers of one another. So remember, isomers mean that they've got the same molecular formula but different structural formula. Both homologous series have the same functional group, that's the carbonyl group, and in many cases they react in similar ways. But when we're looking at partial oxidation, we'll notice something different, okay? Because aldehydes can be further oxidized, but ketones can't. Let's show this with our molecules. Okay, so this is the structure of ethanol. We can further oxidize this molecule because the carbonyl group is at the end of the chain and it still has a hydrogen attached to that carbon. So what in fact happens is that we get rid of this hydrogen and instead we get a hydroxyl group. And that hydroxyl group, remember, if we've got a carbonyl group and a hydroxyl group on the same carbon, that's actually a carboxyl group, like this. Okay, carboxylic acid, so this is now ethanoic acid. If we were to think about oxygen to hydrogen ratios, so when it looked like this, ethanal, this had a ratio of 1 to 4, but when I changed it to ethanoic acid, it's now 2 to 4, which is actually 1 to 2. Okay, so I've increased the oxygen to hydrogen ratio, so this is oxidation. So aldehydes, like ethanol, can be oxidized to carboxylic acids, like ethanoic acid. Now, when we had our ketone, I'm going to show you this with propanone. So this is propanone. when we add our ketone, this carbon here, the carbonyl group in ketone, doesn't have any hydrogens attached to it, so it can't undergo any more oxidation. We can't change the structure of this part now, okay? So aldehydes can be oxidized, ketones can't, and aldehydes are oxidized to carboxylic acids. So the key message here is that aldehydes can undergo partial oxidation, but ketones can't. Now, the oxidizing agents that we can use for that step, so to oxidize aldehydes, are a bit different. There's one that's common, which is the acidified dichromate solution. So that can be used for both alcohols and for aldehydes. So we call that sometimes the universal oxidizing agent. It's the key one to know because it's the one that applies in both situations. But there are two others that we need to know for oxidation of aldehydes. We also need to know Benedict's or Felling's solution. Benedict's is a solution of copper ions, which are blue, and then they get oxidized to this orangey red color. We call that the orange red precipitate, okay, or brick red precipitate. And then we also know Tollin's reagent. So Tollin's reagent contains silver ions, which are colorless, and then when they are reduced, they change into silver atoms. Okay, so remember, oxidizing agents are themselves reduced, so that can help us if we're kind of linking in our Unit 1 knowledge and our Unit 2 knowledge here. So these are the three main reagents you need to know. Okay, so a quick reminder of oxidation and reduction. So they are chemical opposites, and it's important that we feel comfortable talking about different changes between carbon compounds as oxidation and reduction, or oxidation or reduction. So for if I was to say, oh, this secondary alcohol can be oxidized to a ketone, I could also say this ketone could be reduced to a secondary alcohol because they're the opposite, okay? It's like talking about condensation and hydrolysis, okay? So we need to be able to identify a specific reaction as either oxidation or reduction as well. And we need to also be able to talk about the oxygen to hydrogen ratio if it's reduction. So if oxidation is an increase in the oxygen to hydrogen ratio by either increasing the oxygen atoms or decreasing the hydrogen atoms, then reduction is a decrease in the oxygen to hydrogen ratio by either decreasing the oxygen atoms or increasing the hydrogen atoms. Here is a summary of what we've discussed. So we've got primary, secondary, and tertiary alcohols, and we can see that primary alcohols can be oxidized to aldehydes and then to carboxylic acids. Secondary alcohols can be oxidized to ketones. Tertiary alcohols cannot be oxidized. The arrows going horizontally on this page indicate the direction of the oxidation step. The reverse in each case is a reduction reaction. When we're talking about oxidation, this occurs in the context of food because many flavor compounds are alcohols or aldehydes, and so it can change the composition of that food and therefore the taste and flavor if that compound is allowed to oxidize. And that can just happen using the oxygen in the air, although it does happen faster, obviously, if we use an oxidizing agent. An example of this would be in wine. Wine that's exposed to air for a long time will turn into vinegar. The word vinegar actually means bad wine, okay, or sour wine. So that's a kind of real world example of how this happens. And other forms of food spoilage can be attributed to this oxidation reaction. So where the molecules in those foods react with the oxygen in the air and change, and it can change the flavor of that substance. Okay, now we can use an antioxidant to prevent this. Sometimes we use natural antioxidants, but you can also get artificial antioxidants. And the main message for antioxidants today is that they are molecules that play an important role in preventing our food from spoiling too quickly by stopping oxidation reactions from taking place. Okay, so an example would be putting lemon juice onto cut apples to stop those cut apples reacting with the oxygen in the air. The lemon juice instead will react with the oxygen in the air. The antioxidant molecules themselves are reducing agents. They cause other substances to be reduced while being oxidized themselves. And one of the simplest antioxidants is vitamin C. So to recap on today's learning, I know which molecules can undergo partial oxidation using an oxidizing agent. So we should know 3 types of molecules that can do that: primary alcohols, secondary alcohols, and aldehydes. The reason they can be oxidized and tertiary alcohols and ketones can't is because primary, secondary alcohols, and aldehydes all have at least one hydrogen atom attached to the functional group. So that means that there's space for bonds to break and reform in that part of the molecule. I can discuss what happens to the OH ratio during oxidation. So in an oxidation reaction, the oxygen to hydrogen ratio increases. So more oxygens per hydrogen. The opposite is true for reduction. I can name some oxidizing agents and state the relevant color change. So the main one we need to know is the dichromate, which is the orange to green. You also need to know hot copper oxide for the alcohol changes, and then Fellings and Benedicts and Tollens for the aldehyde oxidation. I can use the terms oxidized and reduced to describe the relationship between organic compounds. So we know that they are chemical opposites. And we could say, for example, primary alcohols can be oxidized to aldehydes and then to carboxylic acids and so on. So using the terms like that. And finally, I know how antioxidants work. So they prevent oxidation reactions, for example, in food, and they are themselves reducing agents. Hopefully your notes are complete. You might want to just whiz through the PDF or the PowerPoint yourself to make sure that you're happy. Any questions, let me know.